Now let's do some square root functions. Square root functions are a little bit different than what we've been doing. They have a domain of x greater than or equal to 0 for the parent function y equals the square root of x. Now, of course, for a vertical translation, then we're going to have the square root of x plus d, and if d is positive, then it'll be a shift up, where if d is negative, it'll be a shift down. For horizontal translation, we're going to have this x minus c here underneath the radical. When c is positive, we're going to move c units to the right, and when c is negative, we'll move c units to the left. Now, vertical compression and horizontal stretch, these are incredibly similar. It just depends upon whether your constant is outside of the radical or inside. If the constant is outside and it's greater than 1, then it's a vertical stretch. If it's less than 1, then it's going to be a vertical shrink, so it's going to squish it down a little bit. If A is negative, then it'll be a reflection across the x-axis. Now, if B is inside the radical and it's greater than 1, then it's going to be a compression. And if B is less than 1, it'll be a horizontal stretch. So vertical compression and horizontal stretch can be equivalent depending upon what A and B are. If B is negative, it's going to be a reflection across the y-axis. Now, suppose we have a function y equals 3 times the square root of x. Now, this is going to be a vertical stretch. It'll be a vertical stretch of the function y equals the square root of x. All right? The easiest way to map any square root function is to find that beginning point. So set whatever's in the radical equal to 0, so x equals 0. All right, and then start there and make a table of values. So when x is 0, y is 0. Pick another point, and you're going to want to pick points that make this nice and neat. When x is 1, y is 3 times the square root of 1, or 3. And the next one that we have really is 4. So when x is 4, y is going to be 3 times the square root of 4, which is 3 times 2, or 6. So we can graph those points. Now I've kind of cheated, and I've created a graph like this. And let's see how our points fall. All right, 0, 0, that's our beginning point. 1, 3, so 1, 3. And then 4, 6, 4, 6. All right, once you have 2 or 3 points, you connect them with a smooth curve. And these are actually kind of boring functions because they always kind of increase at this nice little slow rate. Suppose we try another function. Suppose we try y is equal to, y is equal to the square root, whoops, where's my pen there, sorry about that. Y is equal to minus 2 times the square root of x. Now, this is going to be a reflection across the x-axis. So it's a reflection across a line y equals 0, or the x-axis. These are the same. It's going to be a vertical stretch. Factor 2. So you're going to want to do the same thing. You're going to want to make your x, y. You're going to want to start at 0. You're going to want to pick things that have nice square roots. So I'm going to pick 1. When x is 1, y is minus 2 times the square root of 1, or negative 2. When x is, what's the next one? 4. Y is negative 2 times the square root of 4, which is negative 2 times 2, or negative 4. So this is going to give me enough points that I can sketch it. And I see when I sketch it, as I bring it in here, all right, the origin translates to the origin. And you see this is a regular y equals square root of x, just so you can get a feel for what they look like. So this is going to be a reflection across the x-axis and a vertical stretch. So now let me plot the points 1, -2, 1, -2, and 4, -4, 4, -4. All right, now follow this nice curve here. Now, let's see what happens when we move that negative sign under the radical. What's going to happen when I have y equals the square root of -x? This is a reflection across the y-axis. All right, it's not a stretch or a shrink, and it's not been translated. But let me pick my points, x, y. This one, I know that minus x, what's under my radical, has to be greater than or equal to 0. So when I solve this for x, so I multiply the whole thing through by -1, and then I switch the sign, x has to be less than or equal to 0. -1 times 0 is 0. So for this one, the domain is x is less than 0, less than or equal to 0, and the range is going to be y is greater than or equal to 0. So let me plot my points. When x is 0, y is 0. Now I have to go backwards. All right, I have to go left. When x is -1, y is the square root of -1, which is the square root of 1 or 1. When x is -4, y is the square root of -4, which is the square root of 4 or 2. So let me bring up my graph here. When I plot these points, 0, 0, -1, 1, -4, 2. All right. This has the same shape as y equals the square root of x, but it's reflected across the y-axis. Now, let's look at what happens when we throw kind of everything but the kitchen sink in it. Let's look at y is equal to 1/2 times the square root of x minus 3 plus 1. Now, this has a vertical shrink. Factor of 1/2. 1/2. It is a horizontal shift. Right 3 units. And it's a vertical, pin's not working, shift up 1 unit. Let me look at my domain. To find the domain, I take x minus 3 and I make it greater than or equal to 0. So x has to be greater than or equal to 3. So I can't start with any x's less than 3. So x, y. Now this one's going to be a little bit trickier. All right. Let me put in x equals 3. When x is equal to 3, y is equal to 1/2 the square root of 3 minus 3 plus 1. So that's 0. So the whole thing is 1. Now you want to be careful picking your next point. For your next point, you want this to be something that you can take the square root of, like 1. So I have x minus 3 equal to 1. When I add 3 to both sides, I get x is equal to 4. So when x is 4, this is going to be 1/2 the square root of 4 minus 3 plus 1. So it's 1/2 times the square root of 1 plus 1. So that's just 1/2 plus 1. So this is 3/2. So there's my second point. This is a little bit messier than the ones we've been doing. Now, what's the next number that we know square roots nicely when this is equal to 4? So when I add 3 to both sides, I get x equal to 7. So when x is 7, y is 1/2 the square root of 7 minus 3 plus 1. So this is 1/2 the square root of 4 plus 1. So the square root of 4 is 2. So this is 1/2 times 2 plus 1. So this is 1. 1 plus 1, 2. That was a lot of work. So let's graph these. Okay, when I do this, I'm going to graph 3, 1. 1, 2, 3, 1. So that's where this curve begins. 4, 2, 4. Oh no, 4 3/2. 4 3/2, which is right there. And then 7, 2. 6, 7's right there. 2. All right, so and then you have the smooth curve that connects them. So let's see if this makes sense. We did have the vertical shrink. We had a horizontal shift to the right and a vertical shift up.